In these next two examples, we are going to use your graphing calculator quite a bit to solve systems of equations. So our first problem here, example 3a, using a table to solve, I want to look at this problem right here. And instead of rewriting everything on my paper, I'll just show you this screen. The Greenland shark has a birth length of 37 centimeters and a growth rate of 0.75 centimeters per year. The spiny dogfish shark has a birth length of 22 centimeters and a growth rate of 1.5 centimeters per year. If the growth rates continue, how long will each shark be when it's 25 years old? All right, so here's my question. And then after we start working with this, I'm going to add one other part to our question here. All right, back to my paper. So I have the main information written down here. We're a Greenland shark and our dogfish shark. These were their starting lengths and then their growth rates. Well, if I want to figure out some information here, it would be really helpful if I had equations. So let's start off by writing an equation for each shark. Their growth rate for the Greenland shark is 0.75 centimeters per year. Well, since it has that per year, that's my clue that this number is going to have my variable attached. So I'll use y equals 0.75x plus my starting rate, or my starting length. Just like in slope-intercept form, this is my slope, this is my y-intercept. Y-intercept is your starting value, and then slope is our growth rate. And our dogfish shark, similarly, its growth rate is 1.5 centimeters per year. So y equals 1.5x plus 22 centimeters was the original length. So y equals 1.5x plus 22. So again, our first part of our problem is to figure out each shark's length after 25 years. Well, one really easy way to do this, we could plug 25 in for x, and that would be pretty easy. But another thing that we could do is to use our table feature on our graphing calculators. And this is something that you might not have used a whole lot before. So a table is a very helpful feature, and I want to show you guys that. So on your calculator, go to y equals, and type in each equation. If you don't remember, this button right here is what we push to get the x. So our first equation for our Greenland shark is 0.75x plus 37. And then our dogfish shark is 1.5x plus 22. To get to my table, I hit second, graph, see how it says table in the blue, and we get this table. Well, I'm trying to figure out each shark's length after 25 years. Is 25 my x value or my y value? Remember our growth rate was per year, so x is our time. It's our years. So we're looking for when our x value is 25. So we have to scroll down a little ways. Keep going. Here we go. So our first shark was the Greenland shark, and its length would be 55.75 centimeters. Okay, 55.75 centimeters. And then my dogfish shark, after the 25 years, would be 59.5 centimeters. Now I'm going to add one more part to this question here. My other part to this question is after how many years do the sharks measure the same length? Well, we can use our table to help us here also. If our sharks are the same length, their y values are going to be the same. So looking back in my table again, let's see if we can find a place where our y values are the same. And just looking at my screen here, oh, there actually is a spot where our y values, each function's y value is 52. So where those y values are equal is where those two lines, if you think visually, where these two functions would intersect. So after 20 years, those sharks have the same length. Okay, and I will make that note there too. That in the table, the y values will be equal. So that's the gist of using a table to solve a system of equations.